We've been listening to the universe for decades. Ever since the mid-20th century, we have turned our most sophisticated instruments towards the heavens, straining to hear a whisper from the void. It began with Project Ozma in 1960, a pioneering, almost poetic attempt by astronomer Frank Drake to detect interstellar radio signals. He pointed the Green Bank radio telescope at two nearby sun-like stars, Tau Ceti and Epsilon Eridani, hoping to catch the faint artificial murmurings of another civilization. It was a profound expression of scientific optimism. That initial search, lasting just a few hundred hours, found nothing but static and a false alarm from a secret military experiment. Yet, the silence did not deter us. It galvanized us. The search for extraterrestrial intelligence, or SETI, grew from this humble beginning into a global, persistent endeavor. We built larger telescopes, developed more sensitive receivers, and designed complex algorithms to sift through the cosmic noise, searching for a single orderly pattern, a beacon in the dark. We've had tantalizing moments, like the famous WOW signal of 1977, a powerful narrowband radio signal that seemed to bear all the hallmarks of an extraterrestrial origin, but was never detected again, a ghost in the machine. And it hasn't said a word. The Great Silence, as it's sometimes called, is one of the most profound and unsettling puzzles in modern science. It's a silence that grows louder and more perplexing with every new discovery we make about the universe. Every new world we find turns the volume of that silence up a notch. To grasp the magnitude of the silence, we must first comprehend the scale of the stage upon which this cosmic drama unfolds. The observable cosmos spans 93 billion light years. A light year, the distance light travels in a single year, is nearly 6 trillion miles. To traverse our own galaxy, the Milky Way, at the speed of light would take 100,000 years. To reach our nearest galactic neighbor, Andromeda, would take 2.5 million. The edge of the observable universe is a distance so vast it is functionally infinite for any physical traveler. Within this incomprehensible volume, we estimate there are at least 2 trillion galaxies, 2 trillion islands of light, each a sprawling metropolis of stars. Our own Milky Way is just one of them, and it contains up to 400 billion stars. That's more stars in our galaxy alone than there are grains of sand on all the world's beaches. If you were to count them, one per second, it would take you over 12,000 years. And that's just one galaxy among trillions. The sheer number of potential homes for life is staggering. For a long time, we didn't know if other stars even had planets. Now, thanks to missions like Kepler and TESS, we know that planets are not the exception but the rule. We have confirmed the existence of thousands of exoplanets, and statistical projections suggest there are more planets in the galaxy than there are stars. Billions of these worlds are estimated to be rocky, Earth-sized planets orbiting within their star's habitable zone, the Goldilocks region, where conditions might be just right for liquid water to exist on the surface. Not too hot, not too cold. And yet, silence. This is the heart of the Fermi Paradox. The numbers suggest the universe should be teeming with civilizations. The evidence, so far, suggests it is empty. This contradiction forces us to confront a series of profound and potentially disturbing possibilities. The first, and perhaps simplest, is the tyranny of distance. Even if alien civilizations exist, the distances between us are almost incomprehensible. The laws of physics, as we understand them, impose a universal speed limit, the speed of light. Nothing with mass can reach it, and even approaching it requires energies beyond our wildest imaginings. This makes physical interstellar travel a monumental, perhaps impossible, undertaking. But what about communication? Radio waves also travel at the speed of light. A signal sent today from a civilization just 1000 light years away, a stone's throw in galactic terms, would take a millennium to reach us. A reply would take another 1000 years. A simple conversation, a back and forth exchange of hello, would span 2 millennia of human history. That's longer than the entire history of some of our planet's greatest empires. Consider a civilization on the far side of our own galaxy, 50,000 light years away. A signal sent today might arrive long after our sun has swollen into a red giant, engulfing the earth and erasing any trace of our existence. The communication lag across interstellar, let alone intergalactic, distances makes meaningful dialogue a practical impossibility. We are cosmic island nations, separated by an ocean of space-time so vast that even shouting at the top of our lungs for 1,000,000 years might never be heard. And then there's timing. The universe is nearly 14 billion years old. Our species, Homo sapiens, has been around for a mere 300,000 years. Our technological civilization, capable of sending and receiving radio signals, is barely a century old. This is a vanishingly small sliver of cosmic time. Civilizations may rise, flourish for 1,000,000 years, and then vanish all before the first single-celled organism emerged on Earth. The window of opportunity for two civilizations to exist simultaneously and be close enough to communicate might be infinitesimally small. We could be ships passing in the dark of deep time, our brief flashes of existence separated by eons of silence. They may have broadcast their entire library of knowledge into the cosmos, but their signals washed over a primitive Earth, home only to dinosaurs, their message lost to the unlistening past. Or perhaps their signals are on their way now, destined to arrive in a distant future long after we are gone. The cosmos doesn't wait for anyone. This leads to a more ominous possibility, the Great Filter. This theory suggests that there is some barrier, some incredibly difficult step in the evolution from simple life to a galaxy-spanning civilization that is almost impossible to overcome. It could be the jump from non-life to life itself. It could be the leap from single-celled organisms to complex, intelligent animals. Or, and this is the unsettling part, the filter could be ahead of us. Perhaps every technological civilization reaches a point where it develops the means of its own destruction through nuclear war, ecological collapse, or an out-of-control artificial intelligence and inevitably succumbs. In this scenario, the silence of the universe is a warning. It is the sound of countless other species failing their final exam. Or perhaps life itself is the miracle we keep underestimating. The rare Earth hypothesis posits that while simple microbial life might be common, the emergence of complex, intelligent life is an almost impossibly rare event. It requires a chain of events so precise, so improbable that it beggars belief. You need a stable, long-lived star in a quiet part of the galaxy away from the deadly radiation of the core. You need a planet of the right size with a protective magnetic field and plate tectonics to regulate the climate. You need a large moon to stabilize its axis, preventing catastrophic wobbles in its rotation. You need a gas giant like Jupiter further out in the system to act as a cosmic bouncer, sweeping up potentially devastating asteroids. You need a series of evolutionary bottlenecks and triggers, from mass extinctions that clear the way for new life forms to the evolution of photosynthesis that fills the atmosphere with oxygen. The list of cosmic and biological coincidences that had to occur for us to be here is dizzyingly long. Remove any single one, and the entire house of cards collapses. It's possible that this perfect storm of circumstances has happened only once. We may search for centuries and find nothing, not because the universe is empty, but because we are alone in a way we were never prepared to accept. Alone in our intelligence, our consciousness, our fleeting ability to look up at the stars and wonder who else is out there. The silence doesn't mean the search is pointless. On the contrary, it makes it all the more important. It reframes our place in the cosmos. Because if we are the only ones, if this tiny blue world is the only place in this vast, dark ocean where the universe can know itself, then our responsibility is immense. The silence of the cosmos might be the very thing that finally teaches us the value of our own voice and the preciousness of the home that produced it.